In this episode, we focus on a leadership skill that is surprisingly rare right now, evaluating the real business benefits of artificial intelligence, AI, without being fooled by polished demos that do not survive contact with everyday operations. Beginners often assume a demo is evidence that a system works, but a demo usually shows the best-case path under controlled conditions. Production reality is different because real users behave unpredictably, real data is messy, and real systems have uptime, privacy, security, and compliance constraints that demos conveniently ignore. When leaders confuse a successful demo with a ready-to-deploy solution, they can approve projects that burn money, create risk, and disappoint stakeholders. The goal is not to be cynical about AI, because many AI uses truly create value, but to be disciplined about what kind of value is being claimed and what it takes to achieve it. Evaluating benefits requires clear definitions, realistic baselines, and an understanding of what the AI system will actually do once it is integrated into workflows. It also requires separating productivity improvements from automation and separating experiments from commitments. By the end, you should be able to explain why demos can be misleading, what questions reveal production readiness, and how leaders can measure real benefit without letting excitement replace evidence. A helpful starting point is to define what business benefit means in concrete terms, because benefits are often described in vague language like efficiency or innovation. Business benefit should be tied to a specific outcome that matters, such as reducing time spent on a task, improving customer experience, decreasing error rates, increasing revenue, or reducing risk exposure. Beginners should notice that different benefits require different evidence, because saving time is not measured the same way as reducing mistakes. Another key idea is that benefits should be compared against a baseline, meaning what happens today without the AI system, because without a baseline, any improvement claim is just a feeling. A baseline might include average time to complete a workflow, the frequency of rework, or the rate of customer complaints. Leaders need baselines because AI often shifts work rather than eliminating it. For example, moving effort from writing to reviewing, or from manual triage to exception handling. If you only count the time saved in one step but ignore the time added elsewhere, the benefit looks larger than it really is. Clear benefit definitions also prevent the common mistake of building a solution in search of a problem, because the team can test whether the solution actually changes the outcome they care about. When benefit is defined in outcome terms, evaluation becomes grounded and fair. Demos are appealing because they compress complexity into a neat story, but that compression is exactly why they can mislead. A demo typically uses carefully chosen inputs, a cooperative operator, and a controlled environment where edge cases are avoided. In production, inputs are not chosen for you, and edge cases happen constantly, including incomplete data, weird user requests, and unexpected system states. Beginners should understand that many AI models can look brilliant when the prompt is well crafted and the context is clean, yet struggle when prompts are messy or when required context is missing. Another reason demos mislead is that they often hide the costs of integration, such as connecting to internal data sources, enforcing access controls, handling latency, and building monitoring. They also hide the cost of governance, such as controlling data leakage, managing acceptable use, and documenting decisions. Leaders need to recognize that a demo can prove potential but cannot prove reliability, and reliability is what creates real business value. A system that works sometimes can still be valuable if the use case tolerates uncertainty, but for high-stakes workflows, sometimes is not enough. Separating potential from readiness is the core skill here. A practical way to evaluate AI benefits is to classify the use case by the type of work it supports, because different categories have different success criteria. Some use cases are assistive, meaning the AI helps a person do a task faster or better, such as drafting, summarizing, or organizing information. Other use cases are decision support, meaning the AI proposes an answer or a ranking and a human decides whether to accept it. Some use cases are automation, meaning the AI output triggers an action with minimal human review, such as routing a request or approving a routine change. Beginners should notice that the risk increases as authority increases, because an assistive tool can be reviewed easily, while an automated tool can cause harm at scale if it is wrong. Leaders should therefore evaluate benefits in relation to the authority level, Assistive tools might deliver value with moderate accuracy because humans correct outputs, while automation requires higher reliability and stronger controls. This classification also clarifies what kind of measurement is needed, because assistive value can be measured in time saved and user satisfaction, while automation must be measured in error rate, rollback frequency, and incident impact. When leaders know the category, they can match expectations to reality rather than expecting a drafting tool to behave like a deterministic system. Another essential evaluation habit is to examine the data and context the AI system requires, because production systems live or die on inputs. A demo might provide the model with clean, complete context, but in reality, the model may not have access to the necessary information due to privacy rules, system boundaries, or simply missing data. Beginners should understand that AI systems often appear smart because they are given the right context, and when that context disappears, outputs degrade. Leaders should ask what data sources are required, how current and accurate they are, and whether they can be accessed safely with appropriate authorization. They should also ask what happens when the data is incomplete or conflicting, because that is common in real organizations. Another key question is whether the use case relies on sensitive data, because sensitivity increases both risk and compliance burden. If the benefit depends on using data that cannot legally or ethically be used in the way the demo suggests, the benefit is not real. Evaluating benefit, therefore, includes evaluating data feasibility, not just model capability. This is one of the clearest ways to separate demo success from production success. Leaders also need to understand that AI quality is often variable rather than binary, which means evaluation must focus on distributions, not just one impressive example. A demo can show you a single excellent output, but production value depends on the average output and the worst-case output, especially for high-impact workflows. Beginners should notice that many AI systems have a long tail of failures, meaning most outputs are acceptable, but some outputs are very wrong in ways that matter. Leaders should ask how often the system produces unacceptable outputs, what kinds of failures occur, and what safeguards exist to detect and correct them. In assistive use cases, occasional mistakes might be tolerable if review is easy, but in decision support and automation, mistakes can create costly downstream effects. This is why evaluation should include representative test sets and realistic tasks that mirror daily work, not only best-case prompts. Another important point is that users adapt, meaning when people trust a system, they may reduce their own checking, which can amplify harm from occasional errors. Leaders must consider this human factor because it affects real-world error impact. A system's value is therefore tied not only to its capability, but also to how people will use it. A common trap is confusing speed of output with speed of workflow, because AI can produce text instantly while still slowing the overall process. For example, if an AI system drafts content quickly but requires extensive review and correction, the net time saved might be small or even negative. Beginners should understand that review time matters, and review time depends on how trustworthy the output is and how easy it is to verify. Leaders should evaluate the full workflow, including the time spent validating outputs, handling exceptions, and correcting mistakes. They should also consider the cognitive load of reviewing, because reading and verifying can be more tiring than writing, especially if the output is plausible but subtly wrong. Another factor is coordination, because a new AI step may require new approvals, new documentation, or new escalation paths. These additions can slow delivery even if the model is fast. A mature evaluation therefore measures end-to-end impact, not just the speed of the model. When leaders measure the whole workflow, they avoid being impressed by a fast demo that adds hidden friction in production. Another trap is confusing novelty with value, because AI can produce outputs that feel impressive even when they do not improve outcomes that matter. A demo might show a model generating a detailed report, but if that report does not change decisions or reduce risk, it is merely decorative. Beginners should recognize that organizations sometimes adopt AI because it looks modern, not because it solves a real problem. Leaders must therefore ask what decision will be improved, what cost will be reduced, or what customer experience will be enhanced, and how they will know if that happens. They should also consider opportunity cost, because time spent integrating AI is time not spent improving other systems. Another important question is whether a simpler solution could achieve the same benefit, because sometimes the best improvement is process redesign or better data quality rather than advanced modeling. This does not mean rejecting AI, but it means treating AI as one tool among many and requiring it to earn its place. In governance terms, this reduces the risk of chasing shiny objects while neglecting basic controls. True value comes from changing outcomes, not from producing impressive artifacts. To evaluate benefits responsibly, leaders should also insist on clear success criteria and staged validation, because production readiness is demonstrated through consistent performance under realistic conditions. A staged approach might begin with a limited pilot, where the AI system supports a narrow workflow with strong human review. The goal is to measure accuracy, time impact, user satisfaction, and failure modes in a controlled but realistic setting. Beginners should see that pilots are not just proof-of-concept theater. They are evidence-gathering exercises that reveal integration challenges and human factors. Leaders should also require monitoring plans, because performance can drift over time as data changes, user behavior changes, and the organization changes. If a system cannot be monitored, it cannot be governed, and ungoverned systems create risk. Another important aspect is rollback planning, meaning the organization can safely revert if the AI system causes harm or fails. Demos rarely show rollback because demos assume success, but production systems must assume failure will happen sometimes. Staged validation turns excitement into disciplined learning, which is how value becomes durable. Security and privacy also affect whether benefits are real, because controls can change what is possible and what is allowed. A demo might assume the model can access broad internal data, but in production, least privilege and data minimization might restrict access, which can reduce model performance. Leaders should understand that this is not a bug in security. It is a governance requirement, and benefits that depend on bypassing governance are not acceptable benefits. Another security factor is data leakage risk, where sensitive information could be exposed through outputs, logs, or integrations, which can create costs far greater than the productivity gains. Beginners should notice that the value equation must include risk cost, not just productivity gain, because an AI system that saves hours but creates a major data exposure is not a net benefit. Leaders should ask how data is protected, how outputs are controlled, and what monitoring exists to detect misuse. They should also ask who is accountable for incidents involving the AI system, because accountability structures influence how quickly problems are fixed. In production, benefits and risks are inseparable, because the system lives in a real environment with real consequences. Governing AI responsibly means evaluating benefit under the same constraints the organization must live with. When you step back, evaluating AI business benefits without confusing demos with production reality is about demanding evidence that an AI system improves real outcomes under real constraints. Leaders must define benefits in measurable outcome terms, establish baselines, and evaluate end-to-end workflow impact rather than being impressed by fast outputs. They must classify the use case by the authority level the system will have, because assistive tools and automated tools require different reliability and different controls. They must examine data feasibility, context availability, and the distribution of performance, including the long tail of failures that demos hide. They must test under realistic conditions through staged pilots, with monitoring and rollback plans that reflect production needs. They must include security, privacy, and governance constraints in the benefit calculation, because benefits that require unsafe access are not legitimate benefits. For a beginner, the most important takeaway is that a demo proves possibility, not reliability, and reliability is what creates sustainable value. When leaders separate the excitement of what AI can do from the discipline of what AI will do day after day, they make better decisions, reduce wasted effort, and govern risk with clarity instead of hype.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.